So let's talk about the nitration of acetanilide. And this is actually a great example of how to use a protecting group for a synthesis. So if we look at this compound here, our acetanilide, we're going to start with basically the equivalent of a nitrogen-based ester. And this compound, if we start with just aniline, we would actually end up oxidizing this amine, this NH2 group, off of the benzene ring and producing a nitro group. So the reason why we need to start with this compound, with this carbonyl-carbon bound to this nitrogen, is that if we want this reaction to be selective and successful, we can't have a bare amine there. So the addition of this H2SO4 and HNO3, this concentrated acid, creates aqua regia, and this reactive nitro group, the NO2+, is attacked by the benzene ring and undergoes electrophilic aromatic substitution to give us nitro, para-nitroacetanilide. Now, can we get successive replacements? Actually, yes, we can. We have a lone pair on the nitrogen here that will stabilize and basically act as a promoter. So if we're not careful, we run this at high temperatures, and you'll see this in the videos where I'm constantly running it in ice when I can, is to prevent the dinitro complexes from showing up. Now, the next step here is kind of misleading. Yes, the acid is involved, but really here it's the water part that matters. And what the water is doing is that it's deprotecting this amine group. And so when we run this reaction, what we end up producing is an ammonium complex. So first we get the amine, the NH2, and then we protonate it because of all the acid to create this complex. Now we're also going to need to heat this complex as well to kind of drive this reaction. So you'll see this in the video. When we're heating it, that's the reason we're heating it. We're trying to break this nitrogen-carbon bond and deprotect it. The last step here is the addition of base, and the base here will give us our para-nitrogen aniline. Oops, not a 3, that's a 2. And this is our ultimate goal with this synthesis. So, 3 steps here. This one we're going to conduct in ice to prevent the formation of dinitro complexes and trinitro if we're not careful. This is a deprotecting group, and this here with the ammonia is meant to deprotonate, so we're actually able to isolate our desired compound.